In this video, I'm going to walk through an app that I created to score text generations for different models based on the scoring rubric that I've come up with. And I'm using FastHTML along with tons of help from Claude to build this app. What I've done here is I've kind of progressively built up functionality, and eventually we'll get to the final, I think it's about 180 lines of code. But I want to start really simple, and then I want to build up slowly, piece by piece, adding functionality. I'm not a fast HTML expert, so there were some things that I just took Claude's word for it as long as it worked. So I'm sure there's ways to do this in a much more, maybe cleaner, efficient, etc. way. A couple of files that I want to share before we get into this to show where this is coming from. So one file that I have is called criteria.csv, and this has all of the different criteria for all the different scoring categories. So let me zoom out to get everything in one window. So I have grammar, creativity, plot, factual knowledge, reasoning, and context tracking. So I have 6 categories. I have 5 criteria for grammar, 4 for creativity, 4 for plot, 1 for factual knowledge, 1 for reasoning, and 3 for context tracking. And then here's the text of the criteria. So for grammar, for example, criterion A is dialogue formatting and punctuation. Each of these criteria are going to be scored on a 0, 0.5, or 1.0 scale. So 0 means the model failed at exhibiting this criteria or criterion. 0.5 means it was partially successful, and 1.0 means it was fully successful. This comes from the Tiny Stories paper in how they evaluate factual prompts, reasoning prompts, and context tracking prompts. They have this failure, partial success, success scale. So I'm using that scale, just putting some numeric values to it. Not the best way of doing things, but at least for my first iteration, I'm going to stick with that for now. So that's the first file of interest, is criteria.csv. The next file of interest is output.csv. So I have the ID of the given prompt, which is going to be 0 through 149 because I have 150 prompts. The category of the prompt, which is one of those 6 that we saw, the prompt itself, the completion that the model generated, the model name, and then for every category label combination, I have a score column. So grammar A score, grammar B score, grammar C score, etc. Creativity, A, B, C, D, etc. Plot, factual knowledge, reasoning, and context tracking. So this is kind of creating a shell, a template for these scores to be saved to in my app. And then I have the most important piece, which is I have the language model generations. So here is my ID. Oh, actually it goes from 1 to 150, yeah. Then I have category, the prompt, the completion, and then the model name. The categories and the prompts, these are things that I've detailed in a previous video. In short, I started out with the 44 evaluation prompts that were published in the official Tiny Stories paper's dataset repo on Hugging Face. And then I expanded upon those prompts as well as the prompts that they use in, I think, figures 9, 10, and 11 in the paper, where they show, for example, here is figure 9, where they show factual prompts. So they have certain prompts like, what language do they speak in France? Tom asked his mother, and so on. So that's what I'm using as kind of my starting point, and then I used Claude to help me generate more prompts for things like context tracking, creativity, factual knowledge, plot, reasoning, grammar, etc. Grammar was the most simple. I just sampled 5 prompts from the other 5 categories to get 25 prompts for grammar. Reasoning, I used the, I think, 8 or 10 prompts that they had in the paper and then the rest until 25 prompts I had Claude generate. Plot, similar. I used some of the 44 prompts that were conducive to an interesting plot, and then I had Claude generate the rest. Factual knowledge, similar to reasoning, and then creativity, similar to prompt, and context tracking was similar to grammar in the sense that most of the 44 I used for context tracking, because context tracking is, I found, second to grammar, the easiest thing to find prompts for. So this is my data set. Here are the completions that I used or generated using these models. And for completions, I used a temperature of 0 and number of beams equals 5, which I found the authors to post on one of their Hugging Face repos as a guideline to how they generated their text. So this is going to be a key file that we pull from. So lmdata, criteria, and then output.csv. So that's the data that we're dealing with. I have this terminal open and I've run python score.py, and then it's opened this localhost endpoint, and here's my app. So I'm starting out really simple. This is just imports, setting up the app, serving the app, and I have my index page where it takes some index. By default, it takes 0. And right now it's just returning this scoring app. So what do I want to see? Let me see if I have my screenshot. Yeah, don't think I have it in here. But basically what I want to see is I want to see the prompt, the completion. I want to be able to click through the 6 categories for scoring. And then I want to see the criteria. And I want to be able to grade, 0, 0.5, or 1.0. So I'm going to have some text and I'm going to have some buttons, and that pretty much makes up the app. All right, so let's start building up this app a few lines at a time. So the first thing I'm going to do is I'm going to grab my data. And so I'm going to load in the criteria, the lmdata, and the output CSVs. So if I hit save, this will restart the process. And if I refresh the page, it shouldn't break, and it doesn't, so we're doing good. The next thing I want to do is I want to grab one row from my LM data. So I'm going to have this get row, which takes an index, and then it uses the data frame.iloc to return that particular row. And if you remember LM data, it has ID, category, prompt, completion, model name. And so I'm grabbing that information. And let's do one line at a time. So in my index, I'm going to grab the row data, and I'm just going to print it out as is. So if we hit refresh, here we see that it's taken this data frame and it spit out ID 1, category, context tracking, prompt, Alice was born, completion, go to the park, model name, 1 million, and then here's the name and D type of the data frame. So this is good. I'm grabbing some data, it's taking the index value, and it's working. And I think if I go index equals, let's say 200, yeah. So index equals 200, it grabs that value and it prints it off. So far so good. The basic functionality is working. By default, if I don't pass an index, it's using 0. So that's the first piece. Now, obviously, that's not very pretty. I want to see the category. I want to see the prompt. I want to see the completion, and then I don't think there's anything else I want to see for now. So what I chose to do is, let me actually see. Yeah, we'll wait for score 1. So let me keep moving and just get the basic rest of the information in here. So I have my prompt and completion information. It's not formatted, but it's there. The next thing I'm going to do is I'm going to grab a category, and I'm going to get the unique categories in my criteria CSV, and I'm just going to grab the first one, which is grammar. And I'm going to add that to my titled call, and here is grammar. All right, cool. So looks messy, but that's fine for now. I'm going to grab all the categories because eventually these are going to become buttons. So let me put a horizontal rule here so it's a little more legible. And I'm going to print all the categories. Okay, cool. So here's grammar. And then here are all of my categories, all 6 that will eventually become buttons. And then the last thing I'm going to do is that based on the category that's selected, so right now the category that's selected is the first one by default, which is grammar. So I'm going to filter my criteria data frame for grammar, and that's going to be stored in category criteria. And then I'm going to print that out. And I think, yeah, that's the last piece. So I'm going to run this. And here we go. So obviously very messy, but this was my first draft, first iteration, making sure that I can load the data and making sure that I can use some query parameters to grab the data, grab some values, and have them displayed. And even though this is very ugly and messy, the prompting completion is up there, which I want, and then I have the ID, so I want to show some progress about which prompt I'm on. I have the category, I have the list of categories available, and then I have my criteria here. So the core of everything is there. All right, so that's score 0. And now we're going to go to score 1. So now we're going to start using some FastHTML concepts to clean this up. So the first thing I'm going to do is I'm going to create a row class that contains ID, category, prompt, completion, and model name. So ID, category, prompt, completion, model name. And right now these 4 are strings, and these 4 are strings, and the ID is an integer. Then I'm going to add a FT method, a dunder FT method. And the dunder FT method, my understanding is that when you try to render this object, it will, if there is a dunder FT method, it will call it and it will follow whatever's in there to render the HTML. So this is using fastcore's patch. So the object that I'm patching is the row class. And I'm taking self.category and making a p element and calling that underscore category. I'm taking the prompt, putting that in a paragraph element, completion, also throwing that in a paragraph element. And then I'm going to return a div which has category, a horizontal rule, the text prompt colon, the actual prompt, horizontal rule, the text completion colon, and the actual completion. So that is setting up the data class and it's rendering it. So now I need to structure row data so that it uses this data class. And that's what I'm going to do here. So I'm going to grab this and dump it in here. So I have a row class instantiated with the 5 parameters, and I'm passing the row data as ID, category, prompt, completion, model name, which are the things we see here. So now instead of row data, I'm going to pass it that row object. And now if we look at it, it looks a lot better, right? So now we have category, we have the prompt, and we have the completion. And then we have some horizontal rules to kind of distinguish sections from each other. So at this point, I'm like, okay, cool. This is the direction that I want to head. And I feel like I'm using some fundamental ideas about FastHTML to make this more user-friendly. So that takes care of the prompting completion. I'm going to do something similar for the criteria. Yeah, I guess we could do this. So let me just copy this. And let's see. Yeah, so let's copy this. So I'm going to copy this div that I've created. And I'm going to call this criteria for now. And then instead of category, etc., etc., I'm going to render criteria. And if we refresh that, things are a little more structured, still kind of messy, but now I'm going to have the criteria that I'm using at the top, the scores, the categories for scoring beneath it, and then the actual criteria beneath it. So this is where my scorer 1 was. A couple things that I'll change just to align what I'm doing with my scorer 1 file. Instead of having everything in index, what I did was I pulled everything out. And so I have this item handle or route, and this item route takes an index, and then it has my row, get row for that index, and return the row object, which will format like this dunderFD method. So I can get rid of this information here. And then I have now a criteria, which is all this code, except now it's in a separate handler. And criteria takes category, which defaults to none, which is when you load the page initially, and it takes an index, which defaults to 0. Currently, it's not using the index, and it's not even really, we're not really even using category, so it's just defaulting to those values for now. And then from scorer 1, I'm going to grab my index function and replace that here. And all it does is it wraps this item and criteria in a div. And this was something I wasn't familiar with. So what it does is item.to will actually call the function that you have, that route that you have, that name. So that's this one here. And then it'll pass whatever value that you pass here. So it's passing index, and the same thing for criteria is passing index. And right now item is using index, but criteria is not. But if we run that, cool, I get the same result, which is what I expect. All right, so that is scorer 1. So this is our kind of second iteration. We have all of our data here. Scorer 2 is now going to format things so it looks closer to what I'm expecting it to be. So everything up here at the top is the same as before. We have get row, we have the data class row, we have the dunderFT patch, we have the item route, and then item route stays the same. And then the criteria route is where we start getting some interesting things going on. So let's just go top down. So I'm going to have these category buttons. And for each category in categories, so for each one of these, I want to create a button and append it to the list. And then I'll create a div with those buttons called category nav. And then I'll print that out or render that as the first object in the div. So let me just go step by step. So here's category buttons. And let's just render that so we can see what it looks like. Cool. So right now I'm rendering a list. So it has a button for grammar, for creativity, for plot, etc., all the way to context tracking. Then I'm going to create a div with the objects in that list. And instead of rendering the list, I'm going to render the div. And so now this should be my actual buttons. Cool, which it is. And if I widen this a bit, it all fits on one line. And so right now nothing happens when I click these, but at least they're there. Okay, so that's great. What about this one here we can now remove. So let me remove the categories. Okay, so I've removed the categories, so now I have the category that's selected, and there's no functionality yet. And then I have the data frame with the criteria. So here's our category criteria, which is the same thing that we have here. So let's bring this down a bit to match that. All right, so what do we want? I want to be able to see the criteria like A, B, C, D, and then the language, the text of the criteria. And then I want to have 3 buttons, 0.0, 0.5, and 1.0. So that's what happens in this for loop. So first I have my criteria elements. Then I'm going to iterate through the data frame. And I'm going to grab the whole thing for now, but we're going to look at just one piece first. So I'm going to iterate through the category criteria. I'm going to get the row. From the row, I'm going to get the label, which is like A, B, C, D, E, the text, which is the actual criteria text, and then I'm going to append to my list a div that holds some text in a P object, that is the label colon text, and then I have this ID. So criteria elements, now I'm going to replace my category criteria. So it should now render this list. All right, so we see this div, and then we see the P value or the P object, and then we have A, dialog formatting and punctuation, B, tense consistency throughout completion, etc. So you probably see where this is going. Instead of rendering the list, I put an asterisk in front of it, and it's going to, I think the correct term is deconstruct the objects in the list. So there we go. Now I have these divs, and inside those divs there's a P tag and an ID. So now it's really starting to take shape. I want to have buttons associated with every single criteria, and you might be thinking, or at least I was certainly thinking, that I had this nice data class for row, so maybe there's a way I could do a data class for criteria, and I'm sure there is a way to do that. But for now, I just had this for loop and generating this list because I want the buttons to be generated and rendered along with the label and text, because later on I want to have the buttons selected if the score was the button value. So if I, for this prompt in grammar, if I selected 0.5 for criteria on A, and then I navigated away from it or went to the next prompt and came back, I want that button to be selected. So I want it to basically save the score, and rendering it all together in this for loop was one way to allow me to do that. So I'm going to grab these buttons, and then we're going to throw those buttons in a div. Cool. So now I have 3 buttons per criterion, and that looks good. Let's see, I think that's it for score 2. I think everything else is the same. So yeah, that's great. So at this point, everything is pretty much in place. There's a couple, I still need my navigation buttons for navigating forward and backward through the different prompts in my lmdata.csv, but I have my categories for scoring, and then I have my actual scoring values, and then I have the criteria for the given category. So the kind of the data is all there. Now I have to add the actual logic. So that's what I have here as scoring app.py. This is the final version of this app. And so let me just copy all of this, and let's refresh. So this is what the final version looks like, very similar to what we had, but now we have a progress indicator of which item we're on. We have a next and previous button, and you can see the progress indicator updating. And then I can select these buttons, and it switches the category, and it shows the criteria associated with that category. And then the most important part is I can score these criteria for this given prompt and completion. So for example, grammar, I'm selecting all ones. Creativity, I'm going to select all fives. And plot, I'm going to select 0. So now if I go back to output.csv, I should see that grammar has all ones, creativity has all 0.5s, and plot has all zeros. So this is the kind of final functionality that I have, and I'm going to definitely walk through it in a second. But the pieces that we saw were all there. Connecting them was a little complex, and I don't fully have a grasp on it, so hopefully walking through this together will help me out. So let's start from the top. We just have a bunch of CSS. So when the button is selected, we want it to be this color, and when the category buttons are selected, we want it to be this color, and so on and so forth. We are loading the data, nothing different there. Get row, data class, dunder ft, and this part of item. So what's new? So we have this index indicator where it takes the index that you pass it, it adds 1 to it because Python starts with 0, so we want the first item should be 1 in terms of progress. I guess it doesn't have to be 1, but that's what Claude suggested, and I just stuck with it. And then we have the length of the data frame, which is 450. And then we have this index indicator so that we can give it some formatting. So that's straightforward. The previous and next buttons, which are these two here, it calls item.to with index -1 or 0, whichever one's bigger. And so it'll render the previous prompt, or if we get to the first prompt, it'll just keep rendering the first prompt. And then the next button does the opposite. It does either the length of the data frame -1 or index +1. And in each case, this content area is what's being changed. And if we go down to index, this first div that holds the prompt, the category prompt completion, and the buttons and the progress indicator is called content area. Okay, and then nav buttons is just a div that wraps around the buttons. And that's one of the things that we return here. Update criteria I will get to in a second, but first what I want to show is what actually ties together the buttons that I click to the output.csv is this save score method. So we get our row based on whatever index is passed to save score. We also pass the category, so one of these 6, and the label. So, A through E for grammar, A through D for plot, so on. And we generate a string, construct a string that follows the syntax or the naming convention for that scores column in output.csv. So quickly going back to output.csv, here is grammar _C _score. So we're just preparing ourselves to access that column in our output.csv data frame. So if the ID column contains the row data ID, in other words, if there's already an existing row in our data frame for output.csv that contains a score, then we're going to just update the score with df.at. We're going to give it the index that it needs to update, which is the index that is row data.id. And then we are going to pick the score column that it needs to update, and we're going to update it with the score. And the score is passed as an argument to save score. So this is our condition if we are updating a score that already exists. So the next thing is if it doesn't exist in the data frame, we have to create a new row. And we have to create our ID, category, prompt, completion, and model name. So that's a dictionary. And then we're going to add the score column as a key, and the value is going to be the score. We make a new data frame, and then we basically append that new data frame without the index to our originally output scores. So this will add on a new row to output.csv. And then every time save score is called, it saves the output data frame to output.csv. So every time a button is clicked, save score is called, and every time save score is called, the output.csv is saved. So there's a constant saving. There's no submit or save button that you have to click. Every time I click one of the score buttons, it'll automatically save it. So that is the main functionality for saving the scores. How that works, I think, is also a bit involved. So let's walk through it. So here we have our criteria, which is everything beneath this horizontal rule. So all this business down here. So we have our category, which in this case is plot. We are passed an index and potentially a category. And row data is captured for that index. And we get all our categories, we render the buttons. We already saw most of that. The thing that we didn't see was this hxgate method, which basically passes the category and the index to the criteria method. So whenever you click one of these buttons, it passes, plot, or it passes factual knowledge, or it passes reasoning, and then it passes whatever the index is for that item that's being displayed. And then the target is criteria area. So if we go down to our index, this div with all this criteria stuff is called criteria area. And then here, we want to show it selected if cat is category. So if this category value here is equal to the category value that we got from the unique list of 6 categories, then we want it to be the selected class. So plot here is selected, and that's because this value is true. Everything else in the next couple lines we've seen, we have our category buttons in a div, and then here we get our category criteria data frame. And then the next part is the crucial part. So if I'm going to not have a save button, I guess that's less of a thing, but if I want to make sure that what I clicked for the score is persistent, so right now if I go to factual knowledge and I come back to plot, I want these buttons to be clicked. Or if I go forward to prompt 2 and I come back to prompt 1 and I go to plot, I want these 4 buttons that I already clicked to stay there. So I want this persistence of whatever the score is in output.csv. So that's basically what we're going to do here. Let me start with the actual action. So these 3 buttons that I have for each of the A, B, C, D criteria, its class is selected if the current score for that criteria is 0, then the button 0 is selected. Otherwise, it's not. If the current score for that criterion is 0.5, then the 0.5 button is going to be selected, and if it's 1.0, then the 1.0. So right now, I had selected 0.0 for plot A, plot B, plot C, plot D. So the current score in every case for every label text pair here, the current score is 0, so button 0 is going to be selected. So how do we get the current score? Well, what we basically do is we look in the data frame for the given row ID that we have. So whatever index, so here's our get row index, so we get our row data, and then we grab the ID from that and check it with the output data frame, and then we grab that row. So from the output data frame, this is the score data frame, we grab the row where the ID value equals the row corresponding to the index that we have currently selected here. So in this case, index is going to be 0 because this is index plus 1. So we grab our row from the score data frame, and then we iterate through each column in the row. And if the column is a score column, so basically it starts with the selected category, so in this case plot. So if the column starts with plot and ends with score, then we're going to grab the label, which is the second item. So for example, plot underscore A underscore score. Plot underscore B underscore score. So when we split by the underscore, the second value at index 1 is going to be either A, B, C, or D. So we grab the label for that particular column, and then we have this scores dictionary where we're basically mapping the labels A, B, C, D to whatever the scoring column value is. So in this case, scores, we have 0.0, 0.0, 0.0, 0.0. So what this effectively does is it says for the given category that is selected for this index, so for this prompt completion pair, what are the scores, if any, for the criterion that belong to that category. And then we have the same logic as before, where we go through the category criteria data frame, which is just this information, the text information, and then we get the label and text, and we print out the label and text, and then we have our buttons. And here, for the given label, which is A, B, C, or D, we get the score from our scores dictionary, and that's our current score. So all of this is to say that what is selected, which button is selected for each criterion, depends on this line here. The current score comes from the scores dictionary, and the scores dictionary comes from the output.csv. So it's a bit noodle, it's a bit spaghetti-ish code, and I would assume that there's cleaner ways to do this, but I found this to be working okay for now, and I'll probably stick with it unless something breaks. And basically every time you click the button, it calls save score with that category, with that label, so A, B, C, or D. So category is plot, label is A, B, C, or D, and index is whatever the index was, so 1 minus 1 is 0. And so when we go back up to save score, we have our category, label, score, and index. If the index exists in our score, then we update it with the given score. If not, we create a new row, append it to the output data frame, save that as output.csv. And then I think that's it. Yeah, that's back at index where nothing has really changed. So that's the final scoring. If we look at our output.csv, here currently we only have one prompt scored. So let's do another one. Let's go to item 2, and let's say for grammar, let's close this. Grammar, we're going to do all 1s. Creativity, we'll do all 0.5s. Plot, we'll do all 0s. And hopefully, if this works, here we go. So here's our ID equals 2. We have all 1s for grammar, 0.5 for creativity, 0 for plot, and we didn't score the other ones yet. If we go back to ID 1, and then we go to factual knowledge, reasoning, and context tracking, it should now have that populated. So every time this this criteria is called, so if we go back again, so here's our category button. Every time you click one of these category buttons, it passes the category and the index. So every time this, if I click reasoning and the index is 1, it calls criteria with that. And then every time you call criteria, it looks for the scores for that category's criteria. And if those scores do exist, it makes sure to select the correct button corresponding to that score. So that's kind of how it, keeps this two-way persistence. Whatever is clicked here with save score gets saved in the CSV, and then whatever's in the CSV gets rendered as a selected button. So it looks clicked because we already clicked it. And that way I don't have to remember what I scored. As I'm going back and forth, I can see what I scored in the previous iteration. So that is it for the code walkthrough. I'm going to publish this scoring app.py in my TinyScale lab repo. I'll also put up there the output.csv empty, the lmdata.csv populated, and then criteria.csv populated. So all the code will be there. Basically, to run this script, you have to have FastHTML and pandas installed, and when you install pandas, it installs NumPy. I use NumPy, so I can probably get rid of that, but I do use pandas. So you have to have FastHTML and pandas installed, and then you can make sure the CSVs are in the same folder as scoring app.py, and then you can run Python scoring app.py, and it'll spin up the localhost server and give you access to this. So that's it for this. I hope it was informative. It was certainly helpful for me to be forced to explain this, because now I understand it a lot better than I did 30 minutes ago. So thanks for watching. I'll keep the videos coming, and I'll see you next time.